We're going to look at plotting points to make a graph. Let's have a look at an equation like this one over here. Y equals 2x plus 1. Let's get a sense of what are some of the points that will fulfill that equation. So, for example, when x is equal to -2, what will y be equal to? Well, you know how to work that out. You're going to say your y is going to be 2 multiplied by -2 plus 1. 2 times -2 is -4, plus 1 gets you to -3. So when x is -2, your y value is -3. And we can go and plot that point on the graph, right? It is when we go x is -2, the y value is -3. So it's down over here that we would plot the point. The next one, I'm not going to do it as slowly. 2 times -1 is -2, plus 1 gives me -1. I can plot that on the graph. X is at -1 and y is at -1. So there's our point. All right, when you have your x value being 0, your y value is going to be 2 times 0, which is just 0, plus 1, which is 1. And we can plot that. When our x is 0, our y value is 1. Then when x is 1, we're going to have 2 times 1, which is 2, plus 1, which is 3. And so we can plot when x is 1, y is 3. And then for x is 2, you're going to have 2 times 2 is 4, plus 1 gives you 5. So when x is 2, y is equal to 5. Now, if you have a look at all those lines, all those points there, you'll see that they're all sitting in a straight line. And so we can actually join them up with a straight line. And what we get then is that y is equal to 2x plus 1. If we were to plot all the points, we've only chosen to do a few, -2, -1, 0, 1, 2. But if we actually were to do all the points in between, like 1.1 and 1,326 and -593 and all the other points on the entire plane, you would actually get that they would all lie in the straight line. Let's have a look at another one, like this one here, the half x minus 1. So here I'm just again going to choose to look at a few points to get an idea of what's going on. So when x is -4, I will get -2 minus 3, which is -5. When x is -2, I'll get -1 minus 3, which is -4. When x is 0, I'll get 0 minus 3, which is -3. When x is 2, I'll get 1 minus 3, which is -2. And when x is 4, I'm going to get 2 minus 3, which is -1. Now I can go ahead and plot all of those points on this plane. So when x is -4, the y value is -5, so my point is down over there. When x is -2, my y value is -4, so it's over there. When I have x being equal to 0, my y value is going to be -3, so I get a point over there. And when x is 2, my y value that goes with it is -2, so I get a point over here. And then lastly, when x is 4, my y value is -1, so I get a point over there. And again, I can see just from these few points that I've actually plotted that everything seems to be lying in a straight line. So I'm going to join it up with a straight line. And that is giving me the idea of what's going on here, that what I'm going to get, if I carry on drawing this, carry on plotting more and more points, they'll all lie on this straight line. Let's have a look at a last little one, and I'm not even going to do so many points on this one. -x plus 2. Well, when x is negative 3, that'll be negative 3, which is 3. So 3 plus 2 is 5. When x is 0, this is going to be 2. And when x is 3, you'll get negative 3 plus 2, which is negative 1. Let's go and plot those. When x is negative 3, our y value is 5. So it's up there. Plot that point. When x is equal to 0, our y value is 2, so it's up there. And when x is equal to 3, our y value is negative 1, so it's down there. And again, these 3 points are lying on a straight line. And so we kind of can guess that what we're going to get if we try and do a whole lot more points and plot them, we're going to get everything sitting on a straight line. Before we go and have a look at what we've just done in any greater depth, the first question I just want to quickly tackle is it true that any time we've got some sort of an equation and we want to plot the points, that we're going to plot the points and join them with a straight line? Well, let's just have a quick look at this one. If we do x squared minus 3, right, we'll get minus 3 squared minus 3, that's 9 minus 3, which is 6, and minus 1 squared, 1 minus 3, which is minus 2. Here you'll get minus 3. Here you'll get 1 squared minus 3, which is minus 2. And here you'll get 3 squared, which is 9, minus 3, which is 6. So when we go to plot these points, you'll plot them. X is minus 3, y is 6. X is minus 1 and y is minus 2. X is 0, y is minus 3. X is 1, y is minus 2. And then x is 3 and y is 6. Now, I mean, first of all, it goes down and then up, so it's clearly not all in a straight line. And can you see that if you just tried to put a straight line through those, through like these 2 points over here like this, it's not going to go through that one. You know, you can't really join all these 3 up with a straight line. So in fact, actually what this one ends up being is in fact a bit of a curved line like that. I'm not drawing it very beautifully, but it isn't an absolutely straight line. So that's the important thing, that we don't think that every time we have an equation and we plot the points, they're going to be able to be joined up with a straight line. So what made those graphs we looked at earlier special? Why did they end up being straight lines? Well, let's just have a look at what they all had in common with each other. What they had in common is that each and every one of them has got a plane y and a plane x, and then just some numbers that are multiplied with the x or added or subtracted to the x. So if you see what I mean here, by a plane y and a plane x, I mean it's not an x squared or a square root of y or a 1 over x. It's just an x multiplied by something and then something added to it. Here again, you've got an x multiplied by something and something subtracted from it. Here you've got x multiplied by minus 1 and something added to it. So this is the key feature, right? If basically what you've got is you've got an x and a y that are absolutely plain, right? No squared, no square roots, no 1 over x is nothing. And then all you do is you multiply the x by something and some number, not something, some number. And I'm going to just use m to stand for some number. And you add on some number to the end of that, you are going to end up with a straight line graph. So let's just get you to try one so that you can see that what I'm telling you is true. I want you to try one for yourself. Here we've got one in that form I'm told you about, as we've been discussing, right? Y, just a plain y, is equal to some number times x plus another number. And I've told you this will definitely end up being a straight line. So I want you to try that and see if it is true. So go and fill out the table to get points, plot them, and then we'll see, do they lie in a straight line? I'm telling you they will. Okay, pause the video and do that now. Okay, if you did it, you should get a table that looks like this, right? Minus 2 put in here, it's minus 2 times minus 2 is 4, 4 plus 1 is 5, etc., etc. We then go and plot all these points carefully, so when x is minus 2, y is 5, so it's that point there, right? We plot all the other points and we see They do lie in a straight line. Just note this straight line was also coming down and it had a negative, right? That was multiplied with the x. And we saw that in that previous 3 graphs we drew. If there was a positive, it went up. And if there was a negative, it comes down. But we'll explore that a little bit more later. So for now, what I really want you to get out of this is that when we have an equation which is some number times x plus another number, and those numbers can be positive or negative, we are going to end up with a straight line graph. And just be careful, they can disguise it a little bit, right? If you just have it as y minus 3 is equal to 2x, it doesn't look exactly like that, but you are happy enough with working with equations to put that back into the standard form of a straight line. So even if they've tried to disguise it a little bit like this, you'll be able to see that it is actually a straight line.